See, a very important application of gradient is to find out the tangent plane to the level surface. Suppose I assume a level surface, like if I draw a level surface like suppose this green on this surface is level surface fxyz equal to c. The surface which I have drawn by green with the green pen, let's say this is the level surface xyz equal to c, and suppose P is the point xyz at which I want to draw the tangent plane. Let's say O is the origin over here. O is the origin. So let's denote this point P by a position vector small r, and let's say we have a general point on the surface. Say Q, whose coordinate is given by capital X, capital Y and capital Z, right? So let me denote this P, position vector P, by small r vector and position vector of Q by capital R vector, like this. So this is the position vector R and this is the position vector capital R. So this denotes a general point on the surface. See, what is the equation of the surface? Equation of surface is any relation among these three variables will give you the equation of surface. So we have to get a relation between x, y and z. So see, small r is the position vector P at which the tangent plane on the level surface is being drawn. Q is any general point on the level surface. So if I draw a vector from P to Q, obviously since these 2 points P and Q are lying on the plane, so a vector from P to Q will also lie in the plane. So that can be drawn as, so this can be a vector, from P to Q, right? So what is this vector? This vector is small capital R minus small r, right? And see, at point P, if I draw normal to the level surface at point P, that will be normal to the plane also. I can draw it like so. This is normal to the level surface at point P. Obviously, since point P is the point of contact, this is point P. Since point P is the point of contact at which the tangent plane is being drawn, so n is perpendicular to the tangent plane also. Any perpendicular surface, any perpendicular to the tangent plane at that point P. Alright. So I can say that r minus r is perpendicular. Since n is perpendicular to the plane, it is perpendicular to any vector which lies in the plane. So r n can be written as 0. Alright. So I can say n is perpendicular to capital R minus small r, since this vector lies in the plane itself, and n is perpendicular to the plane, and you can have del f, which is perpendicular to the level surface, will be parallel to n. So I can write capital R minus small r dot del f is 0, or I can write I plus y minus yj plus k dot del f by dou x by dou f by dou x I plus dou f by dou y j plus dou f by dou z k equal to 0, or the final equation comes as this: y minus y dou f by dou y plus z minus z dou f by dou z equal to 0. So this is the equation of the tangent plane to the level surface at any point P, whose coordinates are given by a small x, y and z, and capital X, Y, Z is the any general coordinate of any point P on the tangent plane. See, at the same point I can also get the equation of the normal also. See, this normal need not be in direction of r. It looks like n lies in the direction of r, but it's not always. It's only in case of sphere. N need not be in the direction of r. N can be like this also. If I rub this, it's very special case that n can be in direction of r only when it is a hemisphere. Only when it is a hemisphere, it is sphere, right? So this is not a very general thing which I have drawn. Say n is in general, n need not be. I can draw it like this. All right. So what is the equation of this normal? What is the equation of this normal? See, this is point P at which we are drawing a normal, right? If I take any point, any general point, x, y, z over here, x, y, z on the normal, and if I draw a unit vector of this is a point on the normal. Right now, what I am trying to do is, this is the equation of the tangent plane. Now I want to derive the equation of normal, the equation of normal to the tangent, normal to the level surface. The figure will remain same, the figure won't change. Now I am trying to get you the equation of the normal to the level surface, equation of normal to the level surface. We are going to get equation of normal to the level surface. So this is normal. Let's say this is the normal. This is drawn at a point x, y, and z, which is denoted by small r vector. Now if I assume, let x, y, z be at any general point on the normal. So if I draw the position vector of this point also, so this can be the position vector of any general point x, y, and z. So what will be this vector now? This vector will be r minus small r. So what do I conclude? I conclude that r minus small r is a vector lying on the normal, and this is parallel to n, or you can say r minus r vector is parallel to del f. So I can say r minus small r cross del f is 0. This is the equation of normal, which can be written as I j k and say x minus x, y minus y, z minus z, and this is like this. So if you further solve this, what you will get is x minus x del f dou f by dou x, y minus y dou f by dou y, and z minus f dou f by dou z. So this is the equation of the normal, equation of normal to the level surface. This is the equation of normal to the level surface. So this is the equation of normal to the level surface. Now I'll take up some question and use gradient, the concept of gradient, to find the equation of tangent plane and the equation of normal to the level surface. So this is how you find equation of normal, equation of tangent plane to the level surface using the concept of gradient. All right.